Hello everyone, it's Fahim again, and in this video I'll be continuing what I left off in the last tech seminar video. So in the last tech seminar video I talked about data structures and algorithms, but I didn't get into algorithms because the time was up already. So in this video I'll be continuing that and talking about algorithms. So what are algorithms? Algorithms, the most basic definition of what an algorithm is, an algorithm is a series of steps that is used to reach a certain goal or a certain output. So computers are very dumb, right? They don't know anything, but they are very powerful. And to make use of computers, we need to be able to tell computers to do certain things. And since computers are dumb, they can't think for themselves, we need to specify each step that the computer needs to take, right? So how do we do that? Algorithms. So we use algorithms to tell computers to do a certain task for us. That's what algorithms are. And there are many types of algorithms, and today I'll be talking about sorting algorithms, searching algorithms, and also graph algorithms. And before talking about these three types, let's first talk about something called big O notation. So, big O notation is used to assess the performance of a given algorithm. And big O means the worst, how does this algorithm perform in the worst case scenario. And I'll talk about this when I'm talking about each algorithm. And what this is used is for algorithm analysis. So to figure out if this algorithm is better than this algorithm, what are the trade-offs between both of the algorithms, and that's how we make sure we're using the best algorithm for our use case. So now let's get into sorting algorithms. Sorting algorithms, as the name suggests, is used to sort our data in any way that we want. So it can be ascending order, descending order, or some other type of order that can be dependent on anything. So there are a few types, there are a lot of sorting algorithms, and I'll be talking about just a few of them. One of the sorting algorithms, one of the simplest one, is selection sort. In selection sort, if you have an array of numbers, what you do is you go through the array and you find the, if you're doing ascending order, then you find the smallest one and take that and put that into the starting of the array, and then you go on and find the next smallest one, and you go till the end of the array and find the next smallest one, and then you bring it back after the last element, you place that over there and swap the values that was already there. So that's how selection sort works. So what happens is that you are going through the array each time. You won't go through the first part, but you'll go through the rest of the array each time you're going to find that specific smallest value. So that is selection sort, and the next one is bubble sort. In bubble sort, you bubble sort is swapping actually. So what happens is, again, let's take the case of an array that has numbers. In bubble sort, if you're ordering in ascending order, you first start in the beginning and compare the first element and this element that is next to it, that means the second element, and you find which one is smaller. If the second element is smaller, then you swap them, and then you go to the second part, that means the second element, so and you compare them, and if the third element is bigger than smaller than the second element, then you swap those. So what essentially happens is the smallest element is bubbling through the array to the front, right? So that's what bubble sort is. And how do you check when you should stop the iteration through the array? Because um, after we get the smallest element and it bubbles up, then we go through the array again, and then we bubble up the next smallest one. So we stop this algorithm when the number of swaps that we have done after going through the whole array is 0, then we know that the array is sorted already and we stop the algorithm. That's how we stop a bubble sort algorithm. And there's also a much more efficient sorting algorithm called the merge sort, in which it is a divide and conquer method. So you have some data, you split it up into pieces, and you sort those and then bring those together. So what really happens is, you have some big data, you split it up, and then you take this one piece and you split this up, and you take this one piece and you split that up, and you compare until you reach just two elements. You keep splitting, and then this comparison becomes much easier than it will just checking equality, right? So then when we merge them together, we check if we have like, this array has two elements after splitting, and this one also has two elements, and both of these are sorted, right? So this one has the smallest one in the 0 index and the bigger one on the first index. Then we just have to look at both of these first indexes, I mean 0 indexes, and you just insert into the original array the smallest of these two. So this is a much more faster way to do this, but the drawback is that you will need more storage to store all of these merged, I mean split it out and merging all of this stuff. You'll need more memory. So that is about the trade-off that you do. You get either faster sorting with more memory usage, or you get slower sorting with less memory usage. There's always a trade-off in computer science. And that's all about sorting algorithms. Then we have searching algorithms. So this is to find a specific value in a data structure. So there's linear search, which is the most simplest one, in which you have a value that you want to search for, and you have an array that might contain the value. So if our value is 5 and we have an array of 10 elements, then in linear search what you do is, you start at the beginning of the um, array, and you compare each element with our desired element, and when you find that, you just return out the index of that value. So the big O of n of this type of algorithm is, it's big O of n. So that means if you have n inputs, then it will take n amount of iterations or steps to get that value. So, but another more faster way is called the binary search. So in this is how in this binary search, what we do is, we have a sorted array and we have a value, and what we first do is, we split the array. We go to the middle of the array. We don't split the array, I mean we go to the middle of the array, and you check if the value is bigger than or smaller than this specific value. Then if it is smaller, then you get rid of the other part. So that means you have completely gotten rid of half of the problem, right? So the problem is now just half of this. Now in this, you go to the middle again, and then you find out on which side it is, and then split off the other part. So what essentially happens is, if you have, for example, an array of 100 elements, the if we have 100 elements, and in the next case if we have 200 elements, the only difference between these is just one step, because if you have 200 elements, you can just go to the middle, cut it off, and it becomes 100 elements again. So even though the data size increased by double, you just need to do one more step to make it the same as the last size. So this is a much more better method to um, find. And yeah, that's about searching algorithms. Then there's also graph algorithms. I don't completely understand graph algorithms fully, but from what I understand, in graph algorithms there are nodes. So this is used in Google Maps and navigation systems, in which graph algorithms are what are used to find the most optimal route, the fastest route to a specific location. So that's all. I talked about sorting algorithm, selection algorithms, and also graph algorithms. That's all from me. Thank you.